The dream of becoming a citizen of the cosmos was born here more than 2 millennia ago, in the city of Alexandria, named after and conceived by its dead conqueror, Alexander the Great. The Ptolemies, the Greek kings who inherited the Egyptian portion of Alexander's empire, built this library and its associated research institution. Rarely, if ever, before or since, has there been a government that was willing to spend so much of its gross national product on the acquisition of knowledge. And it paid off, big time. Every ship entering Alexandria's harbor was searched, not for contraband, but for books that might be copied and stored here, in what was then the greatest library on Earth. Here, Eratosthenes, one of the chief librarians, accurately calculated the size of the Earth and invented geography. Pythagoras, Hypatia, Euclid, Euclid set forth the precepts of geometry in a textbook that remained in use for 2,300 years. The Old Testament Bible comes down to us mainly from the Greek translations made here. The original manuscripts are the masterpieces of Greek comedy and drama, poetry, science, engineering, medicine, and history. The total work product of the awakening of ancient civilization was kept here. Estimates vary on the total number of scrolls. They range from 500,000 to nearly 1 million. And all of this is but a tiny fraction of the information that you have at your fingertips at this very moment. The collective knowledge of our species, our own electronic Library of Alexandria, may be accessed by anyone who has a device and the interest and the freedom to do so. This was not true in Alexandria, where knowledge belonged to the elite. So in the 4th century AD, when the mob came to destroy the library and the genius of classical civilization, there were not enough people to defend it. What will happen the next time the mob comes? We've come a long way together, traveling from deep inside the heart of an atom, clear out to the cosmic horizon, and from the beginning of time to the distant future. I think we're ready to perform an experiment. It's not the kind of experiment that requires a laboratory. You can do it in your head. It's called a thought experiment. Pick a star, any one of the hundreds of billions of stars in our Milky Way galaxy, which is just one galaxy out of the 100 billion in the known universe. How about that star? Or that one? Okay, this one. It's orbited by dozens of planets and moons. Suppose on one of them, there lives an intelligent species, one of the 10 million life forms on that planet. And there's a subgroup of that species who believe they have it all figured out. Their world is the center of the universe, a universe made for them, and that they know everything they need to know about it. Their knowledge is complete. How seriously would you take their claim? Our ancestors believed that the universe was made for them. It was natural to assume that we were at the center. After all, looks like the sun and stars all revolve around us. We still speak of the sun rising. The architecture of our language, myths, and dreams comes from that pre-scientific age. This is our planet, as it was known then, just before Columbus set sail. This first globe of the Earth was cutting edge when Martin Behaim made it in 1492. Like everyone else, he believed that the jigsaw puzzle of geography was complete. There were 3 continents, Europe, Africa, and Asia, and only the great world ocean in between. Behaim had no clue that North and South America even existed. It's easy to feel smug, right? Well, the fact is, Martin Behaim knew infinitely more about his world, the Earth, than we know about ours, the universe. A recent lesson in humility will serve to illustrate. In 1912, Victor Hess made a series of voyages into the sky above Austria and found the thing that scientists love best, a mystery that defied understanding in terms of conventional scientific wisdom. And even today, a century later, we are still searching for a complete explanation of what Hess found. A new kind of energy had recently been discovered, radioactivity. It was given off by certain elements like radium, but it was also found in the air, even far away from radioactive rocks. It was everywhere. Where did this strange energy come from? No one knew. Hess suspected that it might come from above the Earth. To test his hypothesis, he carried radiation detectors high into the sky. During a risky ascent in a hydrogen balloon, he attained an altitude of more than 3 miles. When he reached the thin, cold upper half of the atmosphere, he found that the radiation was more than twice as strong as on the ground. The radiation must be coming from above. That's why its intensity was weaker on the ground. The Earth's atmosphere was absorbing most of it. Some thought that the radiation might come from the sun. To test that idea, Hess timed one of his ascents to coincide with a solar eclipse. But the eclipse had no effect on the radiation. Hess also found that the radiation was just as strong at night as in daylight. It was coming from above, but not from the sun. What Hess did not know was that the solar wind doesn't move that quickly. And so, for the wrong reason, he came to the right conclusion. Hess had discovered cosmic rays, showers of subatomic particles that crisscross the universe at nearly the speed of light. Without the shielding effect of the Earth's atmosphere, they would be lethal. Some cosmic rays can carry as much energy as a bullet fired from a rifle. It would take decades to trace those cosmic rays back to a death of unimaginable violence. The cosmic rays that Victor Hess detected in the skies above Austria posed a mystery to scientists. Radioactivity in minerals on Earth, like uranium ore, comes from the disintegration of atoms. But cosmic rays were of a different nature. They were far more powerful than anything known in Hess's world. Scientists wondered for 2 decades what could possibly produce cosmic rays. Enter Fritz Zwicky, the most brilliant man you've never heard of. In 1933, he and a colleague discovered that some stars flare up to become as bright as their entire galaxy for a few weeks before fading out again. Fritz Zwicky was the first person to understand what just happened. He correctly surmised that this is the way a massive star dies. It blows its guts out into space. He called this kind of stellar death a supernova. And predicted that the dying star would shrink from about 1 million miles across to only 10. This corpse would be so dense that a single grain of it would weigh as much as the Great Pyramid in Egypt. It would consist almost entirely of subatomic particles called neutrons. So he named these bizarre objects neutron stars. And 35 years after Zwicky predicted their existence, astronomers began to find them. We call them pulsars when they spin rapidly and emit regular pulses of radio energy. Supernovas and neutron stars could account for a wide range of cosmic rays, but not the most energetic ones. Nothing yet known to science can explain them, and we're fine with that. It's one of the things I love about science. We don't have to pretend we have all the answers. Zwicky also came up with the idea that the gravity of a galaxy warps the fabric of space around it to act like a lens. This distorts and magnifies light from any other galaxy lying directly behind it. So astronomers on Earth would see multiple images of that same distant galaxy, deformed as in a funhouse mirror. 40 years after this prediction, we started finding them too. And Zwicky made yet another discovery back in the 1930s. While studying the Coma cluster of galaxies, he noticed something funny about the way they moved. The galaxies were going way too fast. So fast that they should have been flying apart from each other, because all the stars in all those galaxies had far too little gravity to hold the cluster together. Zwicky thought that something else must be binding them to each other. That mysterious missing component would have to weigh something like 50 times as much as the stars themselves. But no one paid much attention to this wild notion. Just another one of Zwicky's crazy ideas. In our solar system, the innermost planet, Mercury, moves much faster than the outermost one, Neptune. And that makes sense, right? The harder you push or pull on something, the faster it goes. The sun's gravity weakens with increasing distance. So the planets that are farther from the sun move more slowly. Everyone expected that the outermost stars in a galaxy would act the same way. Most of the stars are concentrated towards the center, so their collective gravity pulls on the other stars the same way the sun pulls on the planets. But in the 1970s, when astronomer Vera Rubin studied the Andromeda Galaxy, she discovered that the outer stars obeyed no such rule. Unlike the outer planets in the solar system, the outer stars in the galaxy were all going at the same speed as the stars that were closer in, and they were moving way faster than expected. That's funny, Vera thought. Must be something weird about the Andromeda Galaxy. So she looked at another galaxy. Same story. And another. Vera studied 60 galaxies and found that all of them seemed to be violating the law of gravity, a core principle of physics. After some initial healthy skepticism, her colleagues looked for themselves and found that Vera was right. It's not that Isaac Newton had gotten the law of gravity wrong. Vera Rubin had discovered that the gravity of something massive and invisible was forcing the stars to go fast. And then, someone remembered crazy old Fritz Zwicky. And the unknown source of gravity in the galaxy clusters that he called dark matter back in 1933. Vera Rubin had verified the existence of a new, much larger cosmos. And just like the one we thought we knew, it was filled with mystery. Dark matter is completely unobservable, except for its gravitational effect, which makes visible stars and galaxies move faster. Its nature is another deep mystery. Rubin had provided the evidence for an invisible universe nearly 10 times more massive than the one we thought we knew. It was as if we had been standing on the seashore at night, mistakenly believing that the froth on the waves was all there was to the ocean. Vera Rubin looked at the stars and realized they were merely the foam on the waves, and that the greatest part of the ocean remained unknown. But wait, it gets crazier. Our Milky Way galaxy, a few 100 billion stars, plus the clouds of gas and dust, the stuff of once and future stars, and about 100 billion other galaxies. All of that, including those uncounted billions of trillions of planets, moons, and comets, amounts to only 5% of what is actually there. Because there's a bigger unsolved mystery than dark matter: dark energy, which makes up even more of the cosmos and drives its expansion. And it was Fritz Zwicky's supernovas that lit the way to the revelation of its existence. In one scenario, a star consumes all of its nuclear fuel, then cools and suddenly collapses under its own gravity. The star rebounds in a massive explosion, leaving behind a neutron star or a black hole. Since the mass of the original star can fall within a wide range, its peak brightness as a supernova can also vary widely. So you can't tell how far away it is just from how bright it looks. A relatively nearby supernova might appear just as bright as one that was more powerful but farther away. But there's another kind of supernova that comes in only one strength. It marks the violent grand finale of a tango danced by a giant star and a dwarf. As the two stars orbit closely around each other, the giant sheds its outer layers of gas onto the dwarf. When the added weight becomes too much for it to bear, the dwarf detonates like a stupendous thermonuclear bomb. For a few weeks, the brilliance of such a supernova rivals the combined light of all the stars in its galaxy. This kind of supernova always has the same maximum power output, about 5 billion times brighter than our sun. With big telescopes, we can see them in galaxies very far away, out toward the edge of the observable universe. Because all such supernovas have the same wattage, they're ideal tools for measuring distances to the farthest reaches of the universe. We call them standard candles. In 1929, Edwin Hubble discovered that the universe is expanding. The distant galaxies are drifting away from one another. Later, we learned that the expansion began some 14 billion years ago with the explosive birth of the universe, the Big Bang. Everybody assumed that the rate of expansion would be slowing down due to the mutual pull of gravity between all the parts of the universe. If there's enough dark matter, its gravity would eventually bring the expansion to a stop, and the universe would then fall back on itself. In that case, everything would eventually collapse in a big crunch. On the other hand, if the universe had less dark matter, the expansion would continue forever, just getting slower and slower. Two competing teams of astronomers were observing those supernovas in distant galaxies. It turned out to be another one of those "that's funny" moments. In 1998, both teams independently came to the same conclusion. The expansion isn't slowing down at all. It's speeding up. This means the universe will continue to expand forever. There seems to be a mysterious force in the universe, one that overwhelms gravity on the grandest scale to push the cosmos apart. Most of the energy of the universe is bound up in this unknown force. We call it dark energy. But that name, like dark matter, is merely a code word for our ignorance. It's okay not to know all the answers. It's better to admit our ignorance than to believe answers that might be wrong. Pretending to know everything closes the door to finding out what's really there. Tonight, our ships sail into even more exotic waters. Come with me. Only 2 of our ships have ventured into the great dark ocean of interstellar space. The longest odyssey in all of history was launched back in 1977. NASA's Voyager 1 and 2. The Voyagers move about 40,000 miles an hour. They gave us our first close-up look at Jupiter's Great Red Spot, a hurricane 3 times the size of Earth, and one that's been raging since at least 1644, when it was first observed. For all we know, it could be thousands of years old. The Voyagers discovered the first active volcano on another world, on Jupiter's moon, Io, and an ocean beneath the icy surface of the moon Europa, with at least twice as much water as we have here on Earth. The Voyagers dared to fly across Saturn's rings and revealed that they were made of hundreds of thin bands of orbiting snowballs. On Saturn's giant moon, Titan, Voyager detected an atmosphere 4 times denser than Earth's. That hinted at the existence of hydrocarbon seas on Titan, which we later confirmed. Voyager 2 gave us our first portrait of the outermost planet, Neptune. Where the winds roar at 1,000 miles per hour. And its moon, Triton, where geysers of boiling nitrogen shoot 5 miles high. Voyager successfully completed its mission of discovery to the outer planets, but its odyssey into the darkness was just beginning. 35 years after its launch, Voyager 1 became the first of our spacecraft to enter an uncharted realm. The sun is constantly shooting out streams of charged particles in all directions, moving at 1,000,000 miles an hour. This solar wind blows a vast magnetic bubble, our heliosphere, that extends beyond the outer planets. It pushes out against the thin gas of interstellar space. There's a border where one ends and the other begins. Voyager 1 reported back to Earth that its detectors were being pummeled by more and more cosmic rays. Until then, we didn't know where the interstellar ocean began. Voyager 1 pressed on, past a boundary we had never crossed before. The heliosphere shields us from most of the deadly cosmic rays. When stormy solar winds blow, this zone of protection grows. In calm solar weather, it shrinks. When a star goes supernova in our galactic neighborhood, the debris from the exploded star pushes the heliosphere back towards the sun. If it's strong enough to push it all the way back to Earth's orbit, our planet gets a radioactive bath of supernova debris. Luckily, this doesn't happen very often. The last one was perhaps 2 million years ago. A neighboring star explodes 1,000,000 years before there's even such a thing as the human species. How can we possibly know this? Because the dying star left its traces miles below the surface of the ocean. Manganese nodules, small rocks like this one, are scattered over much of the deep sea floor. They grow very slowly. I'm talking 1 millimeter in 1,000,000 years, layer upon layer. These nodules grow in partnership with bacteria by taking up minerals dissolved in the seawater. A supernova produces a radioactive form of iron, unlike anything made by natural processes on Earth. Researchers found telltale traces of this iron in a thin layer below the surface of the manganese nodules. They used the known rate of growth of the nodules to date that layer and to connect it to the fate of a star that perished eons ago. The difference between seeing nothing but a pebble and reading the history of the cosmos inscribed inside it is science. The interstellar ocean is dark and deep. Out here, the sun is just the brightest star in the sky. Yet the Voyagers maintain their regular communications with NASA's Jet Propulsion Laboratory, talking back and forth across the light hours that separate these ships from their home port. No other objects touched by human hands have ever ventured this far from home. Even after they lose their ability to respond to our command, the last and by far the longest phase of the Voyager mission will begin. Back in 1979, when both Voyagers rounded Jupiter, its massive gravity acted as a slingshot, flinging them out of the solar system to travel among the stars of our galaxy. For 1 billion years. Carl Sagan recognized that the Voyager mission offered 2 free tickets to something approaching eternity. He assembled a small team to create a message to any civilization that might one day encounter the derelict spacecraft. 26 centuries ago, the Assyrian king Esarhaddon wrote, "I had monuments made of bronze and inscriptions of baked clay. I left them in the foundations for future times." These hieroglyphics continue that ancient tradition. They are inscribed on the cover of a message designed to be read by the beings of other worlds and times. What could we possibly have in common with an alien civilization with its own separate evolutionary history, and one so far advanced beyond us that they can patrol interstellar space? One thing at least, a universal language: science. It's hard to break the bonds of gravity. You can only sail the cosmic seas if you speak mathematics and physics. Hydrogen is the most common element in the universe. The electron in a hydrogen atom flips the direction of its spin at a constant rate or frequency. Hydrogen atoms are like tiny natural clocks. Tick, tock. Now we have a unit of time in common with the extraterrestrials. This will come in handy when we get to the next level of the message. Here's our return address in space. Pulsars are rapidly spinning neutron stars that give off regular bursts of radio waves. You can set your clock by them. The sun is at the center of this diagram, and the lines point to the 14 nearest pulsars. A simple code labels each pulsar with its unique frequency, using the tick-tock of the hydrogen atom as the unit of time. So alien astronomers could use this diagram to locate the home star of the Voyager spacecraft in our galaxy. They could also tell how long ago the spacecraft was launched. And that's important because the Voyager record has a projected shelf life of 1,000 million years. Become an extraterrestrial archaeologist for a few moments. An artifact has been fished out of the interstellar ocean. It was made by beings that lived about 1 billion years ago. What would you make of them and their world? They've sent us their music and greetings in 59 human languages.
Chân thành gửi tới các bạn lời chào thân hữu.
Hello from the children of planet Earth.
And one whale language. And a sound essay that includes a Saturn V rocket launch. A mother's first words to her newborn baby.
Oh, come on now. Be good for us.
The brainwaves of a young woman newly fallen in love. And the sound of a pulsar. all of that will live for 1 billion years. How long is 1 billion years? If you compress all the time since the Big Bang, the explosive birth of the universe, into a single Earth year, 1 billion years is about 1 month of that year. What was happening on Earth 1 billion years ago? Most of Earth's land was amassed into a supercontinent called Rodinia. It was a barren desert, no animals, no plants. 1 billion years ago, there wasn't enough oxygen in our atmosphere to form an ozone layer. And without it, ultraviolet radiation prevented life from colonizing the land. Rodinia probably looked more like Mars than present-day Earth. The giant world ocean produced huge rainstorms causing flooding and erosion. Glaciers formed, and their slow but relentless movements carved the land into new shapes. Single-celled organisms dominated the oceans, but some existed in colonies called microbial mats, and the first multicellular organisms would soon evolve. And 1 billion years from now, what will Earth be like? Long after our cities, the Egyptian pyramids, the Rocky Mountains have all been eroded to dust? There are few things we can say with confidence about such a far distant time. The only thing we can say for sure is that Earth as we know it will be so changed that we would scarcely recognize it as home. But even 1,000 million years from now, something of who we were and the music that we made in that long ago spring will live on. In that distant future, our sun will have completed another 4 orbits around the center of the galaxy. And the Voyagers will have ventured far from the sun. Carl Sagan was a member of Voyager's imaging team, and it was his idea that Voyager take one last picture. A generation before, an astronaut on the last Apollo flight to the moon had taken a picture of the whole Earth, the planet as a world without borders. It became an icon of a new consciousness. Carl realized the next step in this process. He convinced NASA to turn the Voyager 1 camera back towards Earth when the spacecraft went beyond Neptune for one last look homeward at what he called the pale blue dot.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
How did we, tiny creatures living on that speck of dust, ever manage to figure out how to send spacecraft out among the stars of the Milky Way? Only a few centuries ago, a mere second of cosmic time, we knew nothing of where or when we were. Oblivious to the rest of the cosmos, we inhabited a kind of prison, a tiny universe bounded by a nutshell. How did we escape from the prison? It was the work of generations of searchers who took 5 simple rules to heart. Question authority. No idea is true just because someone says so, including me. Think for yourself. Question yourself. Don't believe anything just because you want to. Believing something doesn't make it so. Test ideas by the evidence gained from observation and experiment. If a favorite idea fails a well-designed test, it's wrong. Get over it. Follow the evidence wherever it leads. If you have no evidence, reserve judgment. And perhaps the most important rule of all, remember, you could be wrong. Even the best scientists have been wrong about some things. Newton, Einstein, and every other great scientist in history. They all made mistakes. Of course they did. They were human. Science is a way to keep from fooling ourselves and each other. Have scientists known sin? Of course. We have misused science just as we have every other tool at our disposal. And that's why we can't afford to leave it in the hands of a powerful few. The more science belongs to all of us, the less likely it is to be misused. These values undermine the appeals of fanaticism and ignorance. And after all, the universe is mostly dark, dotted by islands of light. Learning the age of the Earth or the distance to the stars or how life evolves, what difference does that make? Well, part of it depends on how big a universe you're willing to live in. Some of us like it small. That's fine, understandable. But I like it big. And when I take all of this into my heart and my mind, I'm uplifted by it. And when I have that feeling, I want to know that it's real, that it's not just something happening inside my own head. Because it matters what's true, and our imagination is nothing compared with nature's awesome reality. I want to know what's in those dark places, and what happened before the Big Bang. I want to know what lies beyond the cosmic horizon and how life began. Are there other places in the cosmos where matter and energy have become alive and aware? I want to know my ancestors, all of them. I want to be a good, strong link in the chain of generations. I want to protect my children and the children of ages to come. We who embody the local eyes and ears and thoughts and feelings of the cosmos, we've begun to learn the story of our origins. Star stuff, contemplating the evolution of matter, tracing that long path by which it arrived at consciousness. We and the other living things on this planet carry a legacy of cosmic evolution spanning billions of years. If we take that knowledge to heart, if we come to know and love nature as it really is, then we will surely be remembered by our descendants as good, strong links in the chain of life. And our children will continue this sacred searching, seeing for us as we have seen for those who came before, discovering wonders yet undreamt of in the cosmos.